share with you the, let's say, the method how to solve the power 8. Okay, just trying to first of all fix the voice, the audio. Okay, now I'm going back to Solana on the bus, and through the bus we are going to without listening. Murad Sultan is really the Malik teacher, pioneers in methods. He's now solving groups to the power 8. Okay, this is a new method. Okay, and we try to put to okay. So we thought that this is Murad Sultan is really the pioneers in methods, the researcher, the Tunisian researcher in mathematics fields. Okay, and today we are welcome learners to work through this example. Okay, and today we try to find the roots of eighth degree equation. Okay, so now I'm going to share, let's say, the screen. This is my screen. I'm going to share it. Okay, also the videos. Okay, so now you can at least see the screen. Okay, now learners, this is our example. Okay, this is a polynomial to the power 8. Means that today we are going really to solve the 8 degree equation using the theorem of Mr. Murad Sultan Swedi. Okay, this is our polynomial. Okay, this one. Okay, every one of you has to think of it. Okay, and try to solve this problem. Okay, only by using the disciplinary formula of Murad Sultan Swedi, you can go through finding the roots of these to the power 8. Okay, this is learners the polynomial p of x equal x raised to the power 8 minus 6 to the power 7 plus 7,204 over, let's say, the square of 8 x raised to the power 6 minus 232,832 divided by the cube of 8 times x raised to the power 5 plus learners 4,726,206 over 8 raised to the power 4 x raised to the power 4, of course, minus learners, we can say that, okay, 61,697,912 by the 8 raised to the power 5 times x cubed plus 505,838,740 divided by 8 raised to the power 6 x squared minus learners. Let's see this one, 2,000 and 2,381 353,600 divided by 8 raised to the power 7 times x. That plus 4,928 million 741,769 divided by 8 raised to the power 8 equals 0. So this is learners is the polynomial to the power 8. Okay, it's called 8th degree equation. Mr. Murad Sultan Swedi will show how using or how to use the disciplinary formula of Mr. Murad Sultan Swedi so that you will solve these 8th degree equation. Knowing that before starting, knowing that let's say the roots of this 8th degree equation are all complex roots, complex numbers. Okay, means in this example there is no root. Okay, And here now learners we start. P of x we can write as x raised to the power 8 minus n0 of the cube x raised to the power 7 plus n1 of the cube x raised to the power 6 minus n2 of the cube to the power 5 plus n3 of the cube x raised to the power 4 of all the cube x cube plus n5 of the cube x squared minus n6 of all the cube x plus n7 of all the cube. Now we do challenge solving this 8 degree from the equation. So it's known that this is in fact is 1 to the power 8. Okay, I'll just write this is 8. Okay, this is 1 to the power 8. Our target is to find out the roots of this whole equation so that we should determine the value of SR for the Q relative respect and R of the Q where R belongs to the set of numbers from -1, 0, 1, 3, 4, 5, 6, and 7. Okay, because the highest power is 8, therefore n minus 1 will give you 7. Now we start. We use, let's say, the decimal formula of Murad Sultan's video. Okay, this is the decimal formula. I will show you this one. Okay, this one is called the decimal formula of Mr. Murad Sultan's video. I will make notation for this to show what exactly. Okay, yes, like that. Okay, so this one is my formula. It's called the decimal formula of Murad Sultan's video HSM. Okay. H denote, let's say, the name of my mother, and S the name of my father, and M is Murad. Okay, I'm going to apply this formula so that we can work out the roots of this. Okay, now learners, we should set k equal 0, and this one has to be written as -1 over the R, which is by convention equal what means this is the first coefficient of my new 8 degree from the equation that I'm going to find it out. I'm going also to substitute my discriminant formula so that it will be equal to, I'm going to focus on this, okay, will be negative of 1 times n plus n times n equal n times coefficient of the formula. So this one has to be equal to 0. This substitution, I will make negative combination h is 1 times 16 plus 8 times 16 equal negative 128 plus 128 equal, of course, and now means 0. Now learners, for k equal 2, we find, let's say, I'm going to substitute k equal 2 in my discriminant formula of Murad Sultan's video, or in other words, we can say, according to me, S1 is equal to negative combination 1 choose 1, combination n choose 2 times n0 over the cube, okay, plus n squared times n1. Okay, so this one, learners, is in bracket equal to, after substitution, I'm going to substitute this. I'm going to find the value of S1. Okay, the second coefficient of my new 8 degree formulation. Therefore, learners, of course, we are going to use the coefficient of my 8th degree original polynomial equation, so that it will be S1 equal negative combination h is 2 times 16 squared plus 8 squared times 7,204 divided by x squared. You see, 8 squared and 8 squared will be removed. So therefore, just calculation. I'll just use my calculator to show this for you. Okay, so we have negative combination h is 2. This is 1, 2, so it will be negative 48 times 16 squared times 16 squared. You can see this one, 8 squared divided by 8 squared is 1. I will just write 7,204 plus 7,204. This one has to be equal exactly 36. Okay, so this one is written, is going to be equal to 36. Therefore, now learners, we continue for the next value means that you are going to find S2. This is I'm going to use my discrete formula after setting k equal 3. You see here for k equal 3, we should evaluate S2. Means I'm going to focus on the last formula that has been generalized from my discrete formula, which is this one, two combination n choose 3, n is 8 because the highest power is 8 times n0 raised to the power 3 minus combination n minus 2 choose 1 times n1 plus n cubed times n. There, this is a substitution. Okay, you will get learners. This is our substitution. Will be combination 2 choose. I will just write it here in front of you. So it will be 2 times combination H is 3, 1 to 3 means I'll just write exactly 2 times 1 times combination 3 choose 8. 3 choose 8. This is 1, this is 2, means 56 times 56. Okay, times 16 cubed times 16 cubed. Okay, 16 raised to the power 3. What is it? Raised to the power 3. Okay, then minus combination 6 choose 1 is minus 6. Okay, I'll just write minus 6 times, you see 8 squared and 8 squared, it will be removed. So just write 16 by 7 is equal to times 16 times 16 times 7,240. This one learners, okay, then I'm going to put this here, it is possible. Okay, I'll change the icon of my calculator so that you can see this one, or I will go down, okay, like that. Okay, sorry. Okay, like that. Okay, I will go back to my calculator. Would you just calculate negative 6 times 16, negative 6 times 16 times 700, somehow 204. Plus what? 80 cubed divided by 8 cubed will be removed. Or just like plus 232,832. This one, learners, has to be equal to 0. You see this one? So it's going to be equal to 0. Therefore, the third coefficient of my new eighth degree Coulomb equation is equal to 0. Okay? Now we continue. I'm going to work out, let's say, the value of S3 means you are going to set K equal 4 in the discrete formula of Murad Sultan's vegan, the green one, this one, this one formula. And I'm going to focus on the last one, S3. You see S3 after putting K equal 4 in the discriminant, and after simplifying this, I will get negative combination 3 choose 1 times combination n choose 4. The n is 8 because the highest power is 8 times 0.42 raised to the power 4 plus combination n minus 2 choose 2 times n squared times 0.42 times 1.42 minus combination n minus 3 choose 1 and cube times 0.2 times 0.2 plus n raised to the power 2 times 0. Now just substitution, I'll just write this, okay. So here, learners, you can see this one is combination negative choose 3 times combination 8 choose 4 times 16 raised to the power 4 plus combination 6 choose 2 times 16 squared. 8 squared divided by 8 squared will be 1 times 7,204 minus combination choose 5 choose 1 times 8 cubed. You see this is 8 also against it times 16 times 260,832 plus 1. You see 8 raised to the power 4 by 8 raised to the power 4. No need to type into the calculator, okay, because it's going to be 1 times 4,746,206. Now, if you are looking at the fourth coefficient of the new 8 degree equation is 446. Okay, so every one of you learners, colleagues, and officers try to apply the discrete formula of Murad Sultan because it's gonna be generalized for any algebraic equation. Okay. Now, if you want to calculate it from first view, I'll just write this. Here you can see this one negative 3, 8 choose 4. This is 1, this is 2, this is 3, this is 4. Means 17. So I'm going to write negative 3 multiplied by 17 times 16 raised to the power times 16 raised to the power 4 raised to the power 4. Okay. Then plus combination 6 choose 2. This is 6 choose 1, 6 choose 2 is going to be 15. So that's why I'm going to write here the calculator plus 16 plus 6 plus 15 plus 15 times 8 by 8 squared. It becomes I will just focus on the square of 16. Multiply learners by 16 squared. Okay. Then multiply by 7,204. Multiply by 7,200. And then minus the combination 5 choose 1 is minus 5. Okay, I'll write here minus 5. Okay, times 16. 8 cubed divided by 8 cubed, we cancel it out. Okay, times terms 1 times 16. Okay, times 252,000 times 252,000. Then plus 8 raised to the power 4 divided by 8 raised to the power 4. It will be cancelled. I'll just write plus 4,726,206. I will just plus 4,726,206. This one learners has to be equal to what? As 3 is 4 is 446. Okay, 446. Okay, now I'm going to try to replace this one. So you see here, so this is the value of S3. Means you work it out the value of the coefficient of the value of the fourth coefficient of your new 8-degree polynomial equation that has been derived from the coefficient of the original 8th-degree polynomial equation that I gave from the beginning. Okay. Now after doing that, learners, you should go to find S4. To find S4, according to me, according to my formula, this one, okay, just you are going to put k equal 5, and then you will obtain the fifth coefficient of your new 8th-degree polynomial equation that has to be written as that. Combination 4 choose 1, combination n choose 5, n is 8 simply because you are working with the 8th-degree polynomial equation times n0 for the q raised to the power 5 minus combination n minus 2 choose 3 times n squared, n0 for the q raised to the power 3 times n1 over q plus combination n minus 3 choose 2 n cubed, n0 for the squared times n2 for the cube minus learners combination n minus 4 choose 1 n raised to the power 4 n0 for the q raised to the power 1 times 3 n cubed plus n raised to the power 5 times n4 of all the cube. Now learners, I'm going to focus on this formula so that I will try to work out the fifth coefficient of my new 8th-degree polynomial equation. After calculating this, learners, these are the coefficients that have been colored with yellow will give you, let's say, the coefficient of your new polynomial equation with the highest power is 8. So now I'm going to focus on this. I'm going to calculate this. And in front of you, I will give you 1 minute, learners, to calculate this. So this one has to be equal to 0. I'll just use my calculator. This is my calculator. First of all, I will go down like that, so that I will, yes, like that. Okay. This is the calculator, learners. I'm going to start with okay. That's all. Okay, like that. So we have a combination 4 choose 1 minus 4. I'm going to write 4 minus 8 choose 5. 8 choose 5. This is 1. This is 2. This is 3. This is 4. This is 5. I'm going to use 56. Minus learns 56. Okay. Minus 16 raised to the power 16 raised to the power 5. Okay. To the power 5. Then minus combination 6 choose 3. This is 1. This is 2. This is 3 minus 20. Minus 20. Times learners 16 cubed times 16 raised to the power 3. Okay. Then times 7,200 and times 7,204. And you see this one, 8 squared divided by 8 squared. No need to type it in your calculator because the ratio is going to be 1. Then plus combination 5 choose 2 is 10 plus 10. This is combination 5 choose 1, 5 choose 2. Okay, that's why here I'm going to write 10 here in the calculator. We see this one. Okay, so multiply by 16, multiply by 16 squared. Okay, multiply by 232,000, multiply by 233, 832, sorry. Okay, then plus, this is minus combination function 1 is minus 4, times 16 raised to the power 1. Okay, times learners 4,726,206. So times learners, I could do that 4,000, 4 and 720. Yeah, it's gonna be minus. We told that 4,726,726. Okay, 206. 206. I'm going to check the number first. We have 4,000, 4,000,000 and 726, correct? 206, yes. Then plus learns 8 raised to the power 5 divided by 8 raised to the power 5 is going to be 1. The ratio is 1. Therefore, I'm going to write the last answer is 6,000. So it will be 61 million 29. Then go to using calculator. You will get the value of the fifth coefficient of this is going to be equal to 0. You see, this is my calculator, and you at the same time you are going to use your scientific calculator, and you should find the fifth coefficient of new eighth degree from the equation. Okay, now we move to the next one. I'm going to substitute k equals 6 in the second formula. So this one learners is going to be s subscript k minus 1 equal r equal the sum from 0 to k combination n minus r choose k minus r and raised to the power r cubed k minus r times l r minus is going to be equal to equal learners s5 yes like that. You use it and you get the exact value which is 2,196. So now we got S5 means you find, let's say, out the sixth coefficient of your new eighth degree from the equation that you are going to use after to find the absolutes of these polynomial. Okay, now learners, we can continue this one. I will give you 1 minute, learners, to get or to get the value of S5. Okay. Now, learners, you should find, let's say, k equals 7 in the discrete formula of Murad Sultan Swedi, this one, the green one. So that will find S6. Okay, S6 and S7. So means only two coefficients. Okay. Now, learners, I'm just on the last formula. Okay, this one I'm going to get or to find out the value of First, you see this one as 6. I'm going to give them with another color, with the green color, so it's going to be clear for you. Okay, so this one learns is the seventh option of your new 8-degree polynomial equation that you are going to work it out. Okay, after calculating learners, you can use also you get the science calculator. You get you will find that S6 in fact is going to be equal to an hour. Okay, now I'm going to proceed to continue finding the last coefficient. Then we'll make conclusion about the x roots of this 8-degree polynomial equation. Okay, it's easy in fact. Okay, now substitute k equal 8 in the decimal formula of me, which is s subscript k minus 1 over r equal the sum from 0 to k. Combination n minus r, n is 8, 8 minus r, n is 8, 8 raised to the power r. Between parentheses, negative and 0 point raised to the power k minus r times l r minus 1. Therefore, I'm going to apply this, okay, after simplifying or deriving, let's say, the eighth discrete formula of this operator is really that we took from the beginning, okay? So just have learners S7, the last coefficient, S7 learners has to be equal to exactly to 3,468. Now I can make conclusion means that I let's say find out s minus one, which is one, s0 is zero, s1 is 446, s2 is zero, s3 is 2196, and okay 4 is zero, s5 is S5 is 2196, S6 is 0, and S7 is 3465. Now, learners, I'm going to use to write this differently. In other words, you can see S0 is actually equal to S2, equal S4, equal S6, equal 0, okay? But except S1 is 36, S3 is 446, S5 is 2196, S7 of all the R is 3465. Now we are going to use the method, okay, means I now, let's say, get a new eighth degree polynomial equation, okay, depending on the coefficient of S subscript k minus 1 or the R that has been derived from the decimal formula of Murad Sultan's Swedish. Now, learners, this is x8 minus s0 for the r x raised to the power 7 plus s1 for the r x raised to the power 6 minus s2 for the r x raised to the power 5 plus s3 for the r x raised to the power 4 minus s4 for the r x raised to the power 3 plus s5 for the r x squared minus s6 for the r x plus s7 for the r. Therefore, I'm going to substitute s subscript k minus 1 for the r with their values. Okay, I will obtain x raised to the power 8 plus s1 of all the r x raised to the power 6 because this one is going to be 0. No need to write it. Plus s3 of all the r x raised to the power 4 plus s5 of all the r x squared plus s7 of all the r equals 0. Now, learners, we are going to focus on finding the roots of these eighth degree polynomial equation. In fact, if we are going to let putting x squared equal capital X, you will get fourth degree polynomial equation, and you will solve that. Minus I'm going to square is equal to capital X. So this has to be written as x raised to the power 4, 36 x raised to the power 4 plus 446 x squared plus 2196 x plus 3465. You can see that the roots of this polynomial equation, the roots of this fourth degree polynomial equation is x equal negative 3, and x equal negative 7, and x equal negative 11, and x equal negative 15. That's why the roots of this 8th degree polynomial equation, you will never find the roots. You will get, let's say, complex roots. Therefore, the x roots is the root of plus negative root of 3i, or plus negative root of 7i, or plus negative root of 11i, imaginary of course, okay, plus negative root of 15. Now we are going to show from where we have this one I will solve this and I will explain that negative 3 is a root, negative 7 is a root, and negative 11 is a root, and negative 15 is a root. Okay, let's check this one first. We told that negative. I'll start with negative 3. I will substitute negative 3 in the fourth degree polynomial equation that obtained from the eighth degree polynomial equation, but supposing or putting x squared equal capital X. Therefore, I'm going to write here 3 raised to the power 4 is positive number. So no need to put into parentheses. I'll just write 3 to the power 4, then plus 36 times cube of negative 3 is negative 27. I'm going to write only negative 27 plus 446 plus 446 times the square of negative 3, which is times 9. Then plus 2196 times negative 3, because the root is negative 3. Plus learners plus I'm going to write plus negative 3. This one. Okay, let's do it again. We have negative 3 raised to the power. This is okay. Negative 3 raised to the power 4. Okay. Then we have plus 36 plus 36 times between parentheses, right, negative 3 raised to the power of 3. Okay. Then plus 446 plus 446 times between parentheses, okay, negative 3, close the parentheses, then square the number. Okay. Plus learners 2000 plus 2196 times into parentheses, put the negative number, which is negative 3. Then this one learners negative 3, yes, plus what? Plus 3465. 3465. So this one is going to be in fact equal to 3. If you are going to substitute negative 7, also it will be the same. It will be negative 7, so is a root. Okay, negative 15 is a root. Okay, now you can check this one learned by yourself. Now let's proceed and continue from where we obtain the x roots of this fourth degree polynomial equation that is obtained from the eighth degree polynomial equation. Okay, now learners, we can see that told that negative 3, negative 7, negative 11, negative 15 are called the x roots of this fourth degree polynomial equation. Therefore, the x roots is going to be 24 plus 8 minus 8 minus 24, simply because a 0 for the r equal x1 plus x2 plus x3 plus x4, which is equal 24 plus 8 minus 8 minus 24 equals 0. This is the sum of the x roots of this fourth degree polynomial equation that is obtained from the eighth degree polynomial equation. Now I'm going to square the roots. I will label this as subscript 0 raised to the power 2r will be x squared minus 24 squared plus x2 squared minus 8 squared plus x3 negative 8 squared plus x4, which is equal to negative 24 squared. This one, learners, has to be equal to 1280. But S0 for the r squared is equal to negative S1 for the r. So therefore, after calculating, I'm going to find S1, okay, is equal to negative 640. I will use after to find the new decrement when, let's say, solving to the power 2, okay? Now S3, S0 for the 3 is going to be x1 raised to the power 3 plus x2 raised to the power 3 plus x3 raised to the power 3 plus x4 raised to the power 3 equal 3 times s2. Therefore, this one is going to be 0. Therefore, s2 is equal to 0. You see? So that's why the reason that s1 is going to be different to 0. Now, for the next learners, I'm going to calculate this one. Okay, I will go step by step. The last part, I think, This one. Okay. So therefore, learners as negative 40, if you use the formula of this simulation, really means when substituting k equal to the formula of me, you will get negative 640. S2 now known is the formula. This is the formula, just substitution. You will get S2 is combination choose 1 or choose 3 times negative 36 raised to the power 3 minus combination choose 1 whole square times negative 36 raised to the power 1. Why? Because why it's 4 here? Because now you are going to work with fourth degree polynomial equation. When you told that x square equal to x means you are going to reduce the power. So this one term is going to be equal to 0. That's why here, if you are going to go back, you will get that really the value of S2 is 0. Okay? If you are going to use the first formula of me or the second formula, both of them will need you to try to reach this now. So now S3, it remains on the S3. S3 equal just substitution. It will be, okay, combination 3 choose 1 minus, of course, 4 choose 1 is 1 times negative 36 is 1 over plus 4 squared times negative 36 squared times 406 minus 4 cubed times negative 36 times negative 8,196 plus 4 raised to 4 times 3,165. This one learners, if you would like to calculate it, you will get 3,600 and sorry 36,860. Now you see this one, your polynomial has to be written as that x is s1, okay, x squared plus s3 for the r equals 0, just substitution. Okay, you will get learners s1 is negative 640, s3 is 36,864. Okay, and you will use the decimal formula of v, of course, when putting k equal to and the decimal formula, you will get negative s1 squared plus 4s3. Calculation, just calculate this. This is the sign of multiplication. Sign of multiplication. I will make sign of multiplication is Murad. This one, yes. Okay. Now this one is going to be negative. Therefore, I'm going to put the negative sign equal negative s1 for the q dash. This is the new discriminant. It will be 262,144. This one is the square of 512. Now I'm going to find x square for this polynomial. I will write minus s1 for the r. This is minus, this is positive. I will put minus plus root of negative s1 for the q dash, which is the discriminant. Okay. After calculating, I will obtain the x square equal to 24 squared. Therefore, x subscript k from 0 to 1 is plus negative 24. Therefore, the roots of this polynomial for the power 4 that I obtained from the 8th degree polynomial equation when putting x squared x will be a 0 over the q, which is negative 36, plus x subscript k from 0 to 1. So the first root is negative 3, the second root is negative 15. You see? Now we move to the next part, which is very important. You see here we make plus, then the x squared will be negative. So say 640 minus the root of 512 squared will be 640 minus 512 over 2 gives us 64. 64 is a square number, you can write it as 8 squared or minus square. So x subscript k from 0 to 1 is plus negative 8. Therefore, the roots is a 0.42 plus xk over 8 over 4. Sorry, here this is over 4 over 4 because I'm going to work with the new highest power of the room that I'm working with. It will be negative 7 and negative 11. So I obtain it now fourth x roots. Okay, from the beginning we told that x squared equal capital X. Okay, now this is x squared equal capital X equal negative 3 or negative 7 or negative 11 or negative 15. Therefore, x is plus negative root of I or plus negative root of 7i or plus negative root of 11i or plus negative root of 15i. Therefore, now the roots of my original polynomial equation is L0. L0 is 16. Okay? Plus yk Okay, it's you are going to use positive and negative. So the roots will get eight different roots, which are complex numbers. 16 plus negative root over 3 over 8, or 16 plus negative I root of 7 over 8, or 16 plus I root of 11 over 8, or 16 plus negative I root of 15 over 8. Now, learners, we finished the question, and we really solved the problem about 8 using the decimal formula of Murad Sultan's video. I will explain for you, and start from now, work on learners, and do your best. This is Murad Sultan's video. Okay, now I'm going to stop sharing the screen and telling you goodbye and see you next time. Okay, because now I'm explaining this lecture. Okay, and at the same time I'm going with Salada, okay, and maybe we face some problems in the Wi-Fi, so that's why we stopped there. Okay, thank you and goodbye.